In this video, I'll be talking about the term apparent magnitude, which is used all across astronomy. So in Stellarium, you can click on a star and you'll have a lot of details listed about that star. One of the details is the term magnitude or apparent magnitude. For the star Vega, the apparent magnitude is 0. And if we want to compare that to other stars, let's just go up here where you'll find the Big Dipper, these nice stars here. If you choose these two stars and make an imaginary extension of these two stars of roughly 5 times in the same direction, 1, 2, 3, 4, 5, you'll end up at the star Polaris, which is the North Star. It is in the direction north. So this star is a little bit more difficult to find since it has a lower magnitude. It has a magnitude of roughly 2. And what does this mean in terms of brightness? So in order to quantify that, I suggest that you go to this Wikipedia article about the apparent magnitude. On this webpage, you will find some more details about the apparent magnitude. I want you to turn your attention to this relevant example with the sun and the moon. If we take the example with Vega and Polaris, you should input two numbers, 2.0 and 0.0. So that means that the difference in magnitude is 2. If you put that number into this brightness factor calculation, you can actually calculate it directly on Google. You just say 10 to the power of 0.4 multiplied by 2 minus 0. So the number you get out here is 6.3. That means that Vega is approximately 6 times as bright as the star Polaris. This is how we can use the apparent magnitude. And in reference, you can also go up to this table here, which is really nice. You'll actually see that there's a 2.0 magnitude, apparent magnitude, which is roughly 16% of the brightness relative to Vega. Now Vega is chosen in the system as the reference star. So that's just one important notice in the calculation of the apparent magnitudes. So what else can we use this information for? Now we know that the star Polaris is roughly 6 times as faint as the star Vega. That means that you can use this when you are doing observations of, for instance, Polaris. You know that if you want to take the same picture of Polaris, you should actually change your exposure time relative to the star Vega. So that means that the relative exposure time would be 6 times longer if you wanted to have the same number of photons